A quiet night settles over the planet. City lights dim behind curtains, roads empty, and the sky above turns dark and still. High over the sleeping neighborhoods and silent highways, something small begins to move against that pattern. It is only a soft glow at first, a drifting shadow crossing the familiar constellations. Most people never see it. They are inside, looking at screens or already closing their eyes. But telescopes do not sleep. On mountaintops and desert plains, glass, mirrors and metal domes stare upward, turning slowly, following the whisper of starlight. In their images, this new point of light appears. Faint, steady, moving just a little too fast. Astronomers begin to notice. At first, it looks like another comet, one more icy body falling toward the sun from the cold outer edges of our solar system. They measure its position, mark its path, and feed the numbers into computers. The machines trace a curve, then another, trying to fit an orbit around the sun. But the curve does not close. The line does not bend into a loop. It stretches, open like a door. That is the first sign that this is not an ordinary comet. Its trajectory is hyperbolic, shaped in a way that says, very gently but very clearly, this traveler is not from here and will not stay. It will pass through our sky once and then leave forever, back into the deep dark between the stars. Astronomers give it a name from their catalogs, but on a deeper level they know they are watching the third stranger arrive. Before 3i Atlas, there were two others. The first, called Oumuamua, slipped through in 2017, long and thin like a shard of rock, already leaving by the time we understood what it was. The second, Borisov, in 2019, looked more like a classic comet, a bright head and tail, but it too was on a path that would never bring it back. Now this new object joins them, the third confirmed interstellar visitor, another ancient traveler carrying secrets from a distant sun. If you are listening to this as you drift towards sleep, that is exactly why these stories exist. Somewhere on Earth, in New York at midnight, in London before dawn, in Sydney under bright afternoon light, people press play and look up for a moment. If you want to be part of that quiet constellation of listeners, you can subscribe and share where you are and what time it is. For the narrator, those names and times scatter across the globe like tiny stars of their own. These visitors are not like meteors, burning up in our atmosphere in a quick flash. They are not like the regular comets that loop around the sun again and again on closed orbits, bound by gravity like planets on stretched-out paths. Interstellar objects arrive from outside our solar system, following open trajectories that never loop back. Like a stone thrown past a campfire instead of into a dot. To understand why, imagine our solar system as a small island of light surrounded by a vast dark ocean. Normal comets are like boats tied to that island with invisible ropes of gravity. They may sail far, but they always return. An interstellar object is a piece of wood carried in by the ocean itself, not tied to anything. Here, only passing through on its way somewhere else. Its orbit is tilted, its speed is high, and its path cuts across the sun's pull instead of circling inside it. 3i Atlas moves just this way. Its orbit slices in from the outer darkness, curves gently around the sun, and then bends back out, never closing into a ring. There is something both fragile and powerful in that motion. Fragile, because it will be visible for only a short time. Powerful, because it reminds us that our solar system is not sealed off. It is open to the galaxy, open to messengers we did not invite and cannot hold as telescopes track it. We begin to ask simple questions that carry heavy meaning. What is this object made of? Is it dusty, icy, rocky? Does it shine only by reflecting sunlight, or does it grow a coma? A glowing cloud of gas and dust that spreads around it like a gentle veil as it warms? The answers matter, because they tell. US about the place it came from another star's cold outskirts. Another system's long-forgotten debris, in a calm voice. The story explains the difference between a comet, an asteroid, and this strange in-between visitor. Comets are usually rich in ice. When they approach the sun, they heat up, and the ice turns into gas. That gas carries dust with it, forming a tail that streams away from the sun, lit by starlight. Asteroids, on the other hand, are mostly rock and metal, more like broken pieces of planets than frozen time capsules. Interstellar objects like 3I Atlas can be either. Some behave like comets, with soft halos of gas and tails that stretch for millions of miles. Others, like Oumuamua, do not grow a visible tail at all, leaving scientists puzzled. They sit in a gray space between the names we use, between comet and asteroid, between familiar and unknown. They remind us that our words were invented here, around our own sun, and the universe is not required to fit them. Still, even with simple language, the idea is easy to picture. You can imagine 3IATLAS now. A small body, maybe a few hundred meters or a kilometer across, moving silently through the dark. Around it, a thin cloud spreads, lit by the sun as a soft glow, like breath in cold air. From far away, it is nothing more than a pixel, a tiny point that shifts slightly each night against a fixed background of stars. For a person standing outside on a clear night, it would be almost impossible to see with the naked eye. The sky would look the same as always. Orion over one horizon, the curve of the Milky Way, a plane crossing with its blinking lights. Yet somewhere in that cradle of silence, an unknown traveler is slipping by, older than any mountain on Earth, carrying memories of a place no human has ever seen. There is a kind of gentle fear in that thought, the fragile feeling that comes when you realize how small you are compared to the galaxy. But there is also comfort. If this piece of rock and ice can cross the emptiness between stars, it means the space between those stars is not empty at all. It is filled with motion, with drifting shadows and ancient travelers, with stories written in orbit and trajectory. Instead of ink dot as 3I Atlas is watched night after night, more measurements are made. Each observation adds a dot to its path, refining the curve of its motion. Computers adjust its orbit, drawing a clearer picture of where it came from and where it is going. We can trace its journey backward, away from the sun, past the planets, out toward the unknown. Somewhere in that backward path lies the hint of its origin. Did it wander near an exoplanet, the way comets in our own system swing past worlds and moons? Did it form in the gentle disk of dust around a young star, then get flung out by gravity when giant planets shifted position? Each possibility is like a dream of another sky, far beyond our reach. For now, all we can do is watch. The third stranger in our sky continues its silent passage, a small, steady light in telescope images, a faint echo of a distant system. We know it will not stay. We know it will not return. But while it is here, it offers us a question wrapped in a soft glow. Where did this messenger begin its journey? And what hidden corners of the galaxy has it already crossed on its way to? This brief meeting with our sun? Far above the blue curve of Earth, the sky is not really black. It is a soft, endless night, faintly dusted with stars. Imagine the camera of your mind drifting upward, past the thin veil of our atmosphere, past the slow lights of satellites, until the world below is a small, fragile coin of color. Out here, sound has no air to travel through. There is only silence, and in that silence, something is moving. It is small, darker than the space around it, a drifting shadow against the whisper of stars. This is 3IATLAS, an ancient traveler crossing our neighborhood for the first and only time. It is not born of our sun. It comes from far beyond, from the deep dark between stars, carrying a path written long before humans learned to look up. If you could draw its path across the sky, it would not be a circle like Earth's orbit, or even a stretched oval like many comets. Its track is a long open curve called a hyperbola. A hyperbolic trajectory means this visitor is just passing through. It falls toward the sun, swings around, and then keeps going, forever, leaving our solar system behind. Its orbit is not closed. It is a line through our home, not a loop around it. The direction of that line points roughly toward the constellation Sagittarius, near the crowded heart of the Milky Way. Picture that region as a glowing river of starlight, a soft band across the sky on a clear, dark night. Inside it lie dense star clouds and hidden nebulae, like bright brush strokes across a canvas of darkness. Somewhere from that direction, long ago, 3 idealists was set loose, either drifting at the edge of a distant star's gravity, or thrown outward by a giant planet dot as it floats toward us now. Its motion obeys a few simple rules. Gravity pulls, inertia resists. The sun acts like a silent anchor in space, bending the paths of everything that comes near. If you could see the comet's trajectory traced in thin silver light, you would watch it curve as it falls inward, drawn like a leaf in a slow, invisible whirlpool. Closer to the sun, the curve tightens. Farther away, it straightens, reaching back into the dark. Astronomers describe this shape with numbers. One of those numbers is called eccentricity. A perfect circle has an eccentricity of 0. A stretched oval, like a usual comet's orbit, has a value between 0 and 1. A hyperbola, like the path of 3 IVTLAS, has an eccentricity greater than 1. That single fact tells us that this object is not tied to the sun. It will not return in 1,000 years or 1,000,000. It is a guest, not a resident. Speed is the other key. To stay bound to the sun, an object must move slower than escape velocity at any given distance. 3.1 ATLAS is faster than that limit. Even as the sun's gravity bends its route, it cannot hold onto the comet forever. The comet dives in, gains more speed as it falls, loops around perihelion, the point of closest approach, and then shoots back out, climbing away with enough energy to break free. We are not meeting an interstellar traveler for the first time. Before 3 IATLAs, there was Oumuamua, a strange, tumbling object that did not grow a classic tail. After that came Borisov, a more familiar comet rich with gas and dust. Each followed its own hyperbolic path, racing through our solar system at speeds no ordinary comet from our Oort cloud could match. 3.1 ATLAS joins them as the third known visitor from beyond, another messenger crossing our sky. If you could lay their paths side by side, you would see 3 long curves cutting through the solar system from different directions, like arrows fired long ago from unseen archers. Oumuamua swept past quickly and vanished. Borisov glowed and faded back into the dark. Now 3 IATLAS traces its own line, arriving from the deep dark near Sagittarius and heading towards some future point in the galaxy where we will never follow as the comet falls inward. It does not move through empty space. The space around our sun is filled with the solar wind, a stream of charged particles flowing outward. This wind brushes against the comet, pushing on the thin gas and dust that escape as its frozen surface warms. Gravity shapes its trajectory. The solar wind shapes the veil it carries. Together, these forces create a soft haze around the comet and sweep a tail back along its path. Imagine the comet's motion as a slow dance between 2 partners, gravity and light. Gravity pulls it into a tight swing around the sun. Light and solar wind pull its gas and dust outward, forming a tail that streams behind it like a pale ribbon in a gentle current. In your mind's eye, you can watch the orbit curve and the tail trail as the comet glides closer. then begins to turn away. From far above, if you could see the whole solar system, 3-1 ATLAS would look like a thin, slanted line slicing through a flat disk of orbits. The planets move in almost circular paths, like beads sliding along invisible tracks. The comet, by contrast, comes in at an angle, crossing those tracks, diving through the plane, then rising out of it again. It is a reminder that our system is not closed, that space beyond the planets is open to visitors from the wider galaxy. While all of this unfolds in silence, it also unfolds in time. The comet's journey from the deep dark has likely taken millions of years, yet the part we see, the brief swing near our sun, lasts only months. For most of its existence, 3i ATLAS traveled unnoticed, a frozen body in a vast forgotten corridor of space. Only now, as it cuts through our neighborhood, do we become aware of its presence. As you picture its path, you might feel a quiet sense of wonder. This object has crossed light years of emptiness, guided only by gravity and its own momentum, to pass through a tiny zone where a small planet happens to circle a yellow star. Still, here it is, an ancient traveler threading a needle made of orbits and timing. At this point in the story, we still imagine the comet from the outside as a moving point along a graceful curve. Its hyperbolic trajectory, its speed, its direction. From Sagittarius, all of these can be described with numbers and plotted on charts. But behind those charts is a more human question, one that builds softly in the background. If this visitor has been on its way for so long, how did our species, with fragile eyes and fragile tools, finally come to notice it? Somewhere on Earth, a telescope is watching. Cameras stare at crowded star fields. Software checks for motion. In that sea of tiny lights, one faint dot is sliding from one frame to the next along a hidden path from the deep dark. The orbit is there, written quietly into the images, waiting for someone to trace it. And in that drifting quiet, one could feel that the comet itself has been patient all along, moving steadily toward the moment when human attention would finally catch up to its long, silent journey. Over the high desert of Chile, the night looks almost too rich to be real. Stars spill from horizon to horizon, packed so tightly that the sky seems more light than dark. On a dry plateau, far from traffic and towns, a low concrete building glows with a soft, steady light. Inside, no one is looking up. The universe arrives here as numbers on screens and pale images of star fields. This is one of the Atlas Survey outposts, part of a global warning system that watches for anything wandering too close to Earth. Outside, rounded telescope domes sit like shells under the sky, their narrow openings turned toward the darkness. They move in gentle arcs, taking exposure after exposure of the same regions of space. Every few minutes, a new image is written to disk. Thousands of pinpoints scattered across black dot to a human eye. A single frame is almost meaningless, just a glittering freeze frame of eternity. The secret lies in comparing one moment to the next. In the control room, monitors show sequences of the same star field captured minutes apart. Software aligns them, subtracts what does not change, and highlights what does. Most nights, the output is familiar. Known asteroids drift along mapped paths. Tiny streaks mark meteors burning in the upper atmosphere. Occasional sensor glitches appear and vanish with a few taps of a key. The team on duty has learned the rhythm of this work. They sip coffee and scroll through alert lists, letting their gaze soften so that faint moving points stand out against the static background. On the night of the 1st of July 2025, the routine feels almost sleepy. The air above the mountains is dry and stable, giving the telescopes a clear window into space. The survey program marched through its schedule, returning to fields already imaged many times before. In the data stream, images arrive in quiet succession. Then one of the blinking displays shows something that does not quite fit. On a 4-panel screen, the same patch of sky appears at 4 slightly different times. The stars do what they always do, nothing at all. But in the center left of the field, a faint smear seems to hop from one panel to the next. It is not a sharp dot, but a small, stretched out smudge, barely brighter than the noise around it. The software has already noticed. A tiny box appears on each frame, tagging the moving source. In another window, it's measured positions and brightness. Scroll by in plain text. At first glance, it could be almost anything. A dim near-Earth asteroid, a fragment of an old comet, even a distant object briefly brightened by reflection. The sky is busy, and not every flicker means something new. Yet this smudge refuses to blend back into the crowd. The system checks it against catalogs of known objects. No match. It estimates the rate and direction of motion between frames and feeds those into an orbit solver. A small flag appears beside the result. The path it returns does not curl like a closed loop around the sun. Instead, it stretches outward, open-ended, the shape of a visitor that will not stay. One of the astronomers leans in, replaying the sequence. The room does not erupt. Discovery rarely sounds like shouting. It sounds like silence that lasts a little longer than usual. The astronomer adjusts a few settings, runs the detection, and watches as the smudge still moves the same way, frame after frame, a calm little streak in a sea of fixed lights. Follow-up checks begin almost at once. Other telescopes, some on different continents, are asked to look at the same patch of sky. Larger mirrors gather more starlight, turning the vague smear into a clearer point. Over hours, they trace its motion against the background, measuring how the sun's gravity bends its path but does not claim it. Each new data point tightens the curve, and each one agrees. The orbit is hyperbolic dot in late-night calls and clipped emails. A single word begins to appear beside its provisional designation: interstellar. It is a word that still feels strange. In practical work, like poetry slipped into a lab notebook. The people using it remember earlier surprises. Oumuamua with its mysterious shape and Comet. Borisov with its classic tale, and feel that same quiet astonishment. Back in the Chilean control room, the atmosphere settles into focused calm. The hum of cooling fans, the soft tapping of keys, nothing dramatic has changed. Yet everything feels slightly more sharpened. On one screen, an orbital diagram shows the inner solar system as nested circles. Across them, a thin curve representing. The new object slices in from the direction of Sagittarius and then swings back out, never looping, never closing. If you were there, watching those lines, you might not feel the weight of this right away. To your senses, it is only light on glass. Another line in the table. But quietly, in the language of coordinates and velocities, the universe has just admitted that something from another star has threaded itself through our local map. A dot in the noise has been recognized as a messenger. Later, the first observers will be asked what crossed their minds in that moment of certainty. They might say they thought of the distances involved, of how long this object has drifted through the cold between stars. They might admit that, for a second, they simply stared, feeling a soft, unreasonable hope that perhaps the universe is more connected than it seems. They will remember how the control room lights looked on the floor, and how the night outside felt very large dot as additional. Observatories report in, the numbers grow more confident. A formal name is assigned, 3IATLAS, the third known interstellar object, discovered not by a giant, glamorous observatory, but by a quiet survey whose main job is to guard our planet. In cities far away, people go about their evening unaware that a small ancient traveler has been added to the catalog of things that have come visiting from the deep dark. For Atlas and its team, the work continues. New images arrive, New fields are scanned. The software never stops sorting static from signal. But somewhere in that ongoing stream of pictures and plots, this one object leaves a mark that will not fade. It is proof that the sky above us is not just a fixed dome of familiar lights. It is a highway that other things use, passing through without asking permission. Outside, over the desert, the stars keep burning with their slow, patient glow. No fanfare, no visible sign announces that a stranger has been noticed among them. Inside, on a handful of screens, the trace of 3IATLS persists, a thin curve, a chain of measured points, a faint smear turned into meaning. The computers move on to the next task, but the feeling lingers. Like the echo of a whisper, you are sure you heard dot in that lingering sense of awareness. In that small shift from routine to wonder, something opens. The solar system feels a little less like a sealed room and a little more like a station in a larger network. One stop along a route traced by objects we barely manage to glimpse. And as the night deepens over Chile, it seems that the silence around Earth is not empty at all, but gently crowded with travelers whose stories we are only beginning to hear dot out in the slow dark of space. 3.1 drifts like a tiny seed of ice and dust. It does not know that telescopes on a blue world are turning toward it or the people are weighing every breath of light it sends. It simply moves the way it has moved for a very long time, carrying its frozen story through the cradle of silence around the sun. To understand this wanderer, you have to move close in your imagination. Picture yourself floating beside it, far from clouds, traffic, and wind. There is no sound here, only the faint push of sunlight and the steady pull of gravity. Ahead of you hangs the comet's heart, what astronomers call the nucleus. The nucleus is not a shining ball. It is more like a small dark mountain only a few kilometers wide. Its surface is rough and uneven, built from ancient ices and rock pressed together. You can imagine ridges of dirty ice and plains of fine powder that have not been touched since long before human history began. This little world is fragile. If you could hold a piece of it, far from the sun, it might crumble like packed snow mixed with ash. The ices inside are not only frozen water. They include frozen carbon dioxide and other super cold ices that would boil away in an instant on Earth, preserved for millions or billions of years until the warmth of a star wakes them. As 3.1 ATLAS travels toward the inner solar system, that wake-up call arrives. Sunlight grows stronger. The surface slowly warms. Deep inside, some of the buried ices begin to change straight from solid to gas. Pockets of pressure build. Gas searches for a way out, slipping through cracks and weak spots. When it escapes, it drags dust with it, lifting grains off the surface and releasing them into space. From far away, this slow breathing creates a glowing coat around the dark core, a ghostly atmosphere called the coma. Now the comet no longer looks like a bare rock. It looks like a shadow wrapped in a soft veil of light, a pale cloud hanging around a hidden center. Small but powerful enough to light the space around it. In the coma, sunlight and starlight begin to work their quiet magic. Dust grains catch the light and scatter it in all directions, making the comet appear far brighter than the tiny nucleus could ever be alone. Molecules of gas soak up energy and then release it again, glowing in colors. Too faint for your eyes, but clear to a telescope. The comet does not shout. It glows steadily, like a lantern in a very large room. Step farther back in your mind. So the sun is off to one side and 3.1 is between you and the darkness beyond. From this point of view, you see the next part of its anatomy. The tail. The tail is not a single ribbon. It is a set of structures shaped by light, gas, and the invisible wind that blows from the sun. One part is the dust tail. These are the heavier grains lifted from the surface that now fall slightly behind along the comet's path. They follow their own orbits around the sun, but for a while they stay close, forming a gently curved fan of tiny rocks and powder. When sunlight shines through this fan, it can look golden or white, like a beam of mist stretching across the sky. The other part is the ion tail, made of gas that has lost electrons under the sharp light of the sun and now feels every gust of the solar wind. While the dust tail bends along the comet's track, the ion tail points almost straight away from the sun, a thin, glowing arrow pushed by an unseen hand. For comets that belong to our solar system, this pattern is familiar. From Halley's Comet to far-traveling visitors from the Oort cloud, the same basic anatomy repeats. A small icy nucleus, a bright coma, and one or more tails. They are made of leftovers, circling the sun in long stretched-out orbits that can take decades or millions of years to complete. Everything we see suggests that 3IATLA shares much of this basic structure. Its light brightens as it approaches the sun. Its coma swells, its tail grows, and in images, it looks like many other comets that have brushed the inner planets. On the surface, it appears almost ordinary, a familiar kind of body passing through from far beyond dot to look deeper. Astronomers do more than photograph it. They use an instrument called a spectrograph, which is like a careful prism with a notebook attached. It takes the comet's glow and spreads it into a band of colors, then records how bright each color is. Within that band, certain shades are missing or dim. Others stand out. Together they form a pattern, like a barcode or a simple song that reveals what the comet is made of. Each gas has its own pattern. Water vapor, carbon dioxide, carbon monoxide, and many other molecules leave their fingerprints in the spectrum. By reading these fingerprints, astronomers can tell what the comet contains, even from millions of miles away. When the faint light of 3I Atlas passes through these spectrographs, the patterns point to familiar ingredients. There are signs of water, the same simple molecule that fills our oceans and flows in our veins. There are hints of carbon-bearing gases linked to the clouds from which stars and planets are born. There may be frozen carbon dioxide like dry ice in a fog machine, turning straight to gas as sunlight strikes a dot. In this way, the comet becomes a bridge. On one side is our own solar system, with its planets, moons, and comets made from old stardust. On the other side is the wider galaxy, where other stars have their own disks of gas and dust, their own frozen leftovers. 31ATLAS seems to carry materials that speak both languages. Pieces of it would not look out of place inside a typical solar system comet, or as fragments that one day blaze for a heartbeat as meteors in some distant sky. It is an ancient traveler whose chemistry feels strangely familiar. Now, when scientists look at 3IATLAS, they see all these layers at once. The fragile nucleus, the glowing coma, the sweeping tails, the spectral fingerprints that whisper of water and carbon, a small core, a soft cloud, a tail drawn out by sunlight and solar wind. On paper, its body seems simple, even reassuring, and yet they also remember something important. 3.1. Atlas is not bound to our sun the way homegrown comets are. Its path is not a closed loop but an open curve that will carry it back into the dark between stars. It is a wanderer stopping briefly in the sun's light before moving on, so they keep watching. They trace the shape of its coma, measure the stretch of its tail, and reread the thin lines in its spectrum. Every test says comet, and yet, there is a quiet sense that something does not line up as neatly as expected. For now, you can let the comet drift in your mind as a small frozen mountain wrapped in a glowing veil, drawing a pale mark across space. Its structure seems known, its pieces named, its chemistry gently familiar. But within that very familiarity lies a tiny, persistent wrinkle, like a note in a song that almost, but not quite fits. In that slight, lingering mismatch, the wonder deepens, as if this ordinary-looking wanderer were quietly hiding a secret of its own. Out in the quiet dark beyond Earth, 3-1 Atlas glides along its path like any other icy traveler. From far away, it looks ordinary. A small nucleus of rock and frozen gases wrapped in a thin, ghostly veil. But as it swings closer to the sun, tiny differences begin to appear, like whispers in a song that is almost, but not quite familiar. Most comets behave in ways that astronomers can almost predict by heart. When they are still far from the sun, they are cold and dark, like lumps of sleeping stone. As they drift inward and sunlight grows stronger, the ice on their surfaces warms and turns to gas. This gas escapes into space, dragging small dust grains with it, and a coma, an expanding cloud forms around the core. The solar wind and the sun's light then stretch that material into a long tail that points away from the sun. From the safety of an observatory dome, the rhythm looks steady. Comet brightens, coma grows. Tail lengthens, arching gently away from the sun like smoke from a distant fire. It is a pattern so regular that even amateur skywatchers learn to expect it. At first, 3-1 ATLAS seems ready to play the same role. As it enters the inner solar system, telescopes record a slow increase in brightness, just as the models say it should. But then, in the space of a few nights, something shifts. The numbers jump, like curves graphs that show how brightness changes over time begin to climb more sharply than they should. It is as if someone has quietly turned a dimmer switch much faster than expected. In control rooms around the world, the change is easy to overlook. Computer monitors already glow with data from comets and asteroids. But for those who watch closely, the curve from 3I Atlas has a different slope, a steeper rise that refuses to line up with the smooth, comforting lines of standard comet behavior. The brightening is unusually rapid for an object of its size and distance. Astronomers begin to ask careful questions. Is there a hidden reservoir of fresh ice under the surface, suddenly exposed by a fracture? Are there active regions on the nucleus, small geysers of gas and dust that have just turned toward the sun? Or is there something else in the mix? Some unfamiliar chemistry that responds to heat in a way they do not yet understand. When images of the comet's tail are processed and sharpened, more oddities appear. Instead of a single, gentle streamer, the tail of 3I seems to twist and fork in strange geometry. Portions of it spread sideways, like the ribs of a faint fan. Other parts kink and bend, as though invisible fingers are tugging at them from odd angles. The main tail still points broadly away from the sun, but within that broad stroke there is complexity that refuses to settle into a simple shape. If you could float nearby and look with your own eyes protected, somehow, from the cold and the radiation, you might notice something else. The glow that wraps the comet is not only white or pale green. There are hints of blue, a ghostly tint that does not match what most dusty comets show. In some processed images, the blue-tinged halo stands out more clearly, like a soft neon mist against the dark. Blue, in the language of space, often means energy. Certain gases shine blue when they are excited by ultraviolet light. Some ion tails made of charged particles instead of neutral dust glow with this color as they are pushed almost straight back by the solar wind. Yet even within these rules, 3I seems to be stretching the script. The blue glow appears not just in a narrow ion tail, but as a broader wash around the coma, as if the whole cloud is humming with a slightly different tune. Spectrographs split the comet's light into thin bands, spreading it out into a quiet rainbow of information. Astronomers examine those bands, looking for the fingerprints of known molecules. They see familiar lines, Water, carbon dioxide, perhaps carbon monoxide joining the chorus. But there are also faint hints and blended shapes that do not slot easily into the standard library. Are they noise, tiny errors in the data, or the first signs of some more complex chemistry at work? As the comet comes closer, jets become more obvious. Small bright knots appear near the nucleus, like tiny searchlights, shining through the coma. These are streams of gas and dust, erupting from vents on the surface where sunlight has found a crack or a patch of volatile ice. On most comets, these jets cause gentle changes in spin and slight nudges in the orbit, with 3 IATLAS models suggest. The jets might be stronger than expected, capable of reshaping its path by a measurable amount. The result is a kind of cosmic tug-of-war. Gravity from the sun pulls the comet along a precise hyperbolic trajectory, while the jets push back in small, uneven bursts. Software that predicts the orbit must be updated more often, as if the comet is quietly resisting the neat lines drawn on astronomers' charts. The changes are not dramatic enough to threaten planets or spacecraft, but they are large enough to insist. This is not just another frozen relic passing through. Through all of this, the tone in the scientific community remains calm. There is no talk of danger, only of opportunity. Comets like 3I Atlas are messengers from places between the stars. And when a messenger behaves in an unexpected way, it can teach more than 100 ordinary visitors. Anomalies, those stubborn facts that refuse to fit, are often how science grows, bending theories and nudging equations in new directions. For those following along from home, maybe listening late at night, the story feels both soothing and quietly thrilling. You hear about numbers on screens, about tails that twist and glows that run bluer than they should, but none of it is presented as a warning. It is more like a puzzle laid gently on a table. Here are the pieces: rapid brightening, strange tail geometry, a blue-tinged coma, jets strong enough to alter the path. Somewhere in the way they fit together is a new understanding waiting to be found. Imagine lying back and picturing it all. The sun, a steady lantern at the center, planets circling in their long, patient orbits. And on a path that cuts across their plane, this ancient traveler from another star, shedding light it should not quite have, turning slowly as jets of invisible gas sculpt its course. No one yet knows whether the anomalies come from unusual ices, a tangled magnetic field, or something even more subtle, a layer of material never before seen, or reactions that happen only under the special conditions of interstellar cold and sudden solar warmth. But the questions themselves are gentle companions. They keep astronomers awake in the best way, wondering what small shift in knowledge might come from this wandering point of blue light. As the nights pass, data piles up in digital archives, waiting to be explored. Each new image, each updated orbit, adds another brushstroke to the portrait of 3I Atlas. And still, that faint blue glow remains, an echo in the dark that does not quite match the usual script. It is easy to imagine it as a kind of forbidden signal, not in the sense of danger, but as a quiet message from physics, not yet written down. In the cradle of silence around the sun, the comet continues on its way, shining a little brighter, bending a little differently, humming with colors that ask more questions than they answer. For now, it is simply there, a small, restless note in the great music of the sky, leaving behind a memory of blue light that lingers in the mind long after your eyes have closed and the world around you has fallen softly back into sleep. In the darkness between the planets, the comet is not a sharp point of light, but a breathing cloud. If you could drift beside it, far from the bright noise of Earth, you would see a soft blue haze swelling out from a small, hidden heart. It does not flash or flare. It simply glows, like a lantern wrapped in mist, suspended in the black. This is the coma of 3I atlas. The thin atmosphere that blossoms around its icy core as it falls toward the sun. Most comets, when they wake, shine. With a dusty, reddish hue, their light scattered by countless grains of rock and frozen soot. But this traveler from another star seems different. Its light leans toward blue, like a quiet flame rich with gas instead of dust. And that color becomes the start of a new mystery dot seen through a telescope. The comet is small, only a smear on the sensor. But when astronomers process the image, peel away the background stars, and stretch the contrast, the blue haze stands out. It is not the harsh blue of an electric sign or a screen. It is gentle yet steady, a cool halo that wraps the nucleus in a ghostly shell. Inside that shell, invisible to the naked eye, ice is turning straight into vapor, carving a tiny storm in the vacuum. On Earth, in quiet control rooms and softly lit observatories, the light from that haze is captured and studied. The photons that left the comet minutes ago now fall on mirrors, lenses, and polished glass. They slide down fibers as thin as hair and enter instruments that behave like prisms with a purpose. These are spectrographs, the tools that allow humans to listen to the chemistry of distant objects. A spectrograph takes the comet's pale light and stretches it into a band, from deep red to violet. Then, hidden inside that band, it finds thin, bright lines and dark gaps patterns that are as precise as fingerprints. Each atom and molecule in the comet's coma leaves its mark as a stripe and a particular color. To a trained eye, these stripes are notes in a song. Water vapor, carbon dioxide, carbon monoxide, and more exotic carbon compounds all sing at different wavelengths. On a screen, the spectrum looks simple, a soft rainbow marked by vertical lines. But behind that quiet display lies a story of frozen oceans and ancient dust. When astronomers look at the spectrum of 3IATLAS, they see that its blue glow is not only reflected sunlight. Much of its brightness comes from gas molecules excited by solar radiation, re-emitting that energy as light. The pattern hints at strong emissions from carbon-bearing species and from fragments of water broken apart by the sun. Compared to the reddish comets that often grace our skies, this makes 3I Atlas feel almost like a different kind of visitor. Dust-heavy comets scatter sunlight in warm tones, their tails thick with tiny solid particles. Gas-heavy comets shine with a clearer, cooler light, their halos sculpted by jets of vapor spraying from sunlit cliffs and fractures. In 3I Atlas, the balance leans toward gas, and that tilt gives the coma its gentle, uncanny blue dot. Imagine, for a moment, floating just outside that haze. Around you, grains of dust drift like slow snow, but most of what surrounds you is invisible. A thin, expanding shell of gas racing away from the nucleus in all directions. Sunlight passes through it and wakes up the molecules, lifting their electrons to higher states, then letting them fall again. Each fall releases a tiny pulse of light in a very specific color. Multiply that by trillions and you have the comet's glow, a chorus of microscopic transitions blending into a steady, luminous breath. From Earth's distance, that breath is faint. Telescopes must track the comet carefully as it moves, nudging their mirrors to follow its arc across the sky. Long exposures gather the light over minutes and hours, slowly deepening the signal. The background stars smear into short streaks, but the comet stays sharp enough to study. In the data, astronomers notice that the profile of its glow, the way brightness falls off from the center, matches a gas-rich coma more than a dusty one. Back in the lab, models are run, changing the amounts of water, carbon, and dust to see which combination best recreates the spectrum and brightness. The numbers suggest a coma rich in volatile ices, materials that evaporate easily in sunlight. Some of those ices are common, the same ingredients seen in many comets of our own solar system. Others appear in ratios that feel slightly off, like A familiar melody played in a different key. Nothing impossible, but enough to make careful observers pause. The blue color itself does not mean danger. It is only a sign of which molecules are active, which parts of the comet are waking up as it nears the sun. Still, in the quiet hours of the night, it is easy to feel that the glow carries a message. Not a warning, but a reminder. This object was shaped in a different environment, under the light of another star. Its chemistry reflects that distant birthplace, preserved for millions or billions of years, and now slowly unwinding in our sky, dotting away. The spectrographs are listening. Across that time, they translate cold interstellar history into bands of color and lines of data. To most people, those lines are only marks on a screen. To the scientists who study them, they are clues about pressure, temperature, and the mix of elements in the cloud. They reveal whether the coma is smooth or patchy, whether the jets are strong or weak, whether the comet's surface is uniform or broken into regions that wake at different rates as the nights pass. Observers notice small changes. The blue halo brightens and softens. Subtle asymmetries appear on one side of the coma, a little sharper, a little more extended, as if a hidden jet is pushing more gas in that direction. These hints suggest structure, perhaps arcs or fans of gas within the haze, shaped by the comet's rotation and by the direction of the solar wind. The instruments cannot yet see these structures directly, but their effects echo in the light. For now, the view remains simple. A soft blue glow, a few pixels wide, set against the black. Yet inside that glow, the physics is busy and precise. Molecules collide, drift, and break apart. Ions feel the tug of magnetic fields carried by the solar wind, tracing invisible paths outward. Dust grains are nudged by both light and gas, beginning journeys that may eventually end as meteors burning in some distant planet's sky. From a human perspective, all of this happens in silence. There is no sound in the vacuum around the comet. Only the quiet translation of light into data, and data into understanding. The mystery is not loud. It is patient. It asks only that someone, somewhere, is willing to sit in the dark, point a telescope at a faint blue smudge, and listen. As 3 IATLAs continues its dive past the sun, its glow will change. Some gases will fade as the comet moves away. Others may flare briefly as new patches of ice are exposed. The balance between dust and gas will shift. And in that shifting light, in the way the brightness stretches and thins, there may be more than just a pretty halo. Hidden within its glow, the shape of its tail and the delicate structures of its dust may be waiting, keeping their secret patterns just out of easy sight. Like a quiet thought at the edge of a dream dawn, in almost every children's book and classroom poster, a comet looks simple. The sun sits on one side, the comet on the other, and a long, glowing tail streams neatly away from the light, like a paint stroke pushed by an invisible hand. It feels fixed in our minds, almost like a rule. The tail always points away from the sun. So when early images of 3I Atlas begin to arrive, and astronomers notice a bright spike apparently pointing back toward the sun instead, something inside that picture cracks. It is a small change, just a sliver of light at the wrong angle, yet it lands like an unexplained word in a familiar sentence. The first time you see the images, you might think someone labeled them wrong. In the frame, the comet's core glows as a small, soft blur. One tail stretches away into the dark, as expected. But near the head, another bright line seems to lean toward the sun's direction, like a finger pointing the wrong way. For a moment, the universe looks disobedient, as if this ancient traveler has ignored a basic law of light and wind. Even seasoned observers, used to tricks of orbit and perspective, feel a brief shock of awe and unease. The calm voice of the documentary leans in to explain. It reminds you that a comet does not have just one kind of tail. There is the ion tail, made of gas stripped and pushed by the solar wind, always pointing almost straight away from the sun. And there is the dust tail, made of heavier grains, more loyal to the comet's own trajectory. These particles follow the orbit like a faint drifting shadow, lagging behind as the nucleus moves on. When 3IATLAS sweeps past the inner solar system, it leaves behind not just a streak, but a wide, thin sheet of dust spread along its path. Now, imagine that sheet as a flat ribbon laid along the comet's orbit. From high above, it would look like a pale band, curving gracefully around the sun. But you do not see it from above. You see it from a small, moving world, Earth circling its own path, looking across space at an angle that is always changing. There are moments when that sheet lines up just so that you are staring almost edge-on through the dust. What is wide and thin looks, from your vantage point, like a narrow spike. It doesn't really point toward the sun. It simply lies along the orbit. Yet from Earth, in that fragile line of sight, it seems to. The narrator compares it to driving through falling snow at night. When you look straight ahead, the flakes race toward you in bright streaks, as if the storm is coming from a single point. In truth, the snow falls gently in all directions. It is your motion and your eyes that make the pattern. The anti-tail of 3IATLAS is like that. Dust grains drift in the cradle of silence around the comet, but from Earth, they're slow. Balanced motion turns into a sharp, sunward spike. The geometry is simple. The feeling when you first see it is anything but. Telescope operators study the images on their screens, tracing angles, plotting the orientation of the comet, the sun, and the Earth. As they do, the anomaly softens into understanding. The forbidden pattern is not the comet breaking the rules, but the universe quietly reminding us that rules sit inside perspective. Change where you stand, and the same dust, the same orbit, the same gentle veil of particles will draw a different picture on the sky. In the control rooms, the mood returns to calm curiosity. Still, no one quite forgets that first jolt, the sense that the sky itself had leaned in to whisper something hidden. Out beyond the math, the comet continues its slow, precise dance. Dust grains peel away from the nucleus, tiny fragments of rock and ice warmed loose by sunlight. Some are pushed hard by the solar wind, swept into the familiar tail you expect from any comet. Others, heavier and more stubborn, stay closer to the original trajectory, forming that thin sheet that 3IATLAS drags along like a memory of where it has been. Each grain reflects starlight in its own small way, and together, they become the brushstroke across the sky that startled human eyes. What looks like a single bright spear is really countless pieces, each following its own quiet path, as the days pass, and Earth moves along its orbit. The angle changes again. The anti-tail shortens, then shifts, then fades back into a more ordinary shape. For many casual watchers, the moment passes unseen. For those who caught it, a bright spike that seemed to violate the simple picture of a comet, it becomes a story they will tell later, a reminder that even well-known objects can surprise us. In that sense, the anti-tail is not just an optical effect. It is a small lesson in humility, drawn in dust and starlight. The cosmos is timeless, but our viewpoint is fragile. And yet, underneath the explanation, a whisper of unease remains. If a thin sheet of dust can play such tricks on the human eye, what else might be hiding inside the glow of this interstellar visitor? The same data that explains the anti-tail also reveals subtle changes in brightness, faint shifts in the way the coma spreads, small differences from night to night in where the light seems strongest. Astronomers begin to ask careful questions about the comet's path, its acceleration, its mass loss. The anti-tail was only the first sign that what You see, is not always the full story. So the chapter settles into a soft, reflective calm. You can picture the comet now. A pale head, multiple tails, dust like slow snow, all wrapped in a soft glow against the darkness. You know, the anti-tail is a matter of geometry, perspective, and motion, not a breaking of cosmic law. Yet the memory of that wrong way spike lingers, like a dream you can't quite shake. In the quiet that follows, as telescopes continue to track this ancient traveler, there is a sense that if dust and light can deceive so gently, the deeper motion of the comet, its very trajectory through space, may hold another secret, waiting in the drifting dark to be understood. Out in the slow dark of the solar system, paths are a thing. Planets move along their orbits like grooves in an old record. Moons follow them. For the most part, space is a map that repeats itself. That is why, when 3 IATLAs arrived, astronomers drew its path with the same quiet confidence they use for everything else. They measured its position against the background stars. They watched how fast it moved. They fed those numbers into their computers, and on their screens, a thin curve appeared. The comet's expected trajectory, a smooth arc that cut through the inner system and then slipped back out into the deep. On those screens, the curve glowed like a promise. If gravity was the only force at work, 3I Atlas would follow that line exactly. Every night, telescopes around the world would look up, and the comet would be right where the curve said it would be, like a traveler following a carefully drawn road. Night after night, the tiny dot of the comet appeared where it should. Observers in quiet mountain observatories and backyard telescopes alike recorded its position. Each new point landed neatly on the plotted line, like beads on a string. The orbit model held. Then, slowly, the dots began to drift out at first. The change was so small that it looked like noise, like the kind of error that comes from shaky air or imperfect instruments. A data point sat just a little to one side of the line. Another point, on another night, landed a little above it. The difference was tiny fractions of an arcsecond, the width of a distant hair. On the sky, to the human eye, it was invisible. But on the computer plots, the pattern started to whisper. Something was pulling 3I Atlas off the road. Astronomers did not jump to wild ideas. They checked their clocks and their software. They compared measurements from different observatories under different skies. When the same small shift kept showing up in data taken by different teams on different continents, the whisper became a quiet statement. The comet was not exactly where gravity alone said it should be. In the gentle light of their screens, the thin curve of the predicted orbit still held its shape. But now, the real positions of the comet formed a second, slightly bent line beside it. It looked as if the traveler had begun to walk along the edge of the road, pushed sideways by some unseen breeze. That breeze, they knew, was not really wind. It was the comet itself. As 3I Atlas moved closer to the sun, its frozen surface began to warm. Ices that had slept for long ages began to turn straight into gas. This process, called outgassing, is common in comets. It is what creates the coma, the glowing cloud around the nucleus, and the tail that streams away from the sun. But outgassing can also do something quieter and stranger. It can push. You can imagine the comet as a slowly spinning rock of ice, with jets of gas shooting out from its surface like tiny, invisible fountains. Each jet carries mass away, and as that mass pushes off into space, it exerts a small force in the opposite direction, like the thrust from a rocket engine. On a single night, that push is almost nothing. Spread over weeks and months, it adds up. The result is something astronomers call non-gravitational acceleration. The phrase sounds cold, but the idea is simple. Instead of moving only under the formula, pull of the sun's gravity, 3IATLAS is also being nudged by its own breathing. Every jet that switches on or off, every patch of ice that cracks and wakes up, changes the balance of those tiny pushes. The comet does not just fall. It steers in its own slow, uncontrolled way. On paper, the effect shows up as a small extra term in the equations of motion, a quiet correction to a familiar law. On the sky, it shows up as those drifting dots, stepping away from the predicted line. In the mind, especially late at night, it feels like something more, a reminder that even in a fortress of predictable orbits, there can be one restless visitor that refuses to stay in place. In low, warm control rooms, astronomers updated their models. They added non-gravitational terms tuned to match the data. The new curve wrapped itself around the comet's true positions, like a hand adjusting to hold a living, moving thing instead of a stone. But the feeling of strangeness did not go away. Part of the unease came from how strong the effect seemed to be. For non-gravitational acceleration to matter this much, 3I Atlas had to be losing mass quickly. Jets were turning on and off like valves in a system no one controlled. Some nights, it might push a little harder. Other nights, the thrust could fade or shift to a new part of the surface. Each change twisted the comet's path a little more. In your mind's eye, you can picture it. An ancient shard of ice and rock, spinning through sunlight, its surface cracking and sighing. Thin plumes of gas shoot out into the dark, curling and vanishing, while the whole body wobbles under their tiny kicks. From far away, it looks calm, a steady glow moving across the stars. Up close, it is a storm of small forces, always changing. For researchers, this behavior is not just curious. It is a gift. Non-gravitational accelerations carry clues about the comet's inner life. The strength of the push hints at how much ice is turning to gas. The direction of the push hints at where the active regions are, which side of the nucleus is venting the most material. By tracking the way 3ITLA slips from its old path to a new one, scientists can build a quiet, indirect map of its activity. Night after night, the plots grew. The thin dots marked a path that was no longer a simple arc, but a story about loss and change. Inside that wandering object, ices were vanishing into space. Dust was peeling away. The nucleus was becoming lighter, its center of mass shifting. Its spin perhaps changing in answer. Around it, the solar system still acted like a fortress of patterns. The planets kept their orbits. The moons kept circling their worlds. The asteroid belt remained a quiet river of rock. But through that clockwork moved this one object that did not quite obey, that let its own escaping breath steer it away from the path gravity had chosen. Even here, in one of the most predictable systems we know, there is room for a little wandering. The laws still hold. The math still works. But within those laws, there is space for a traveler that shrugs off the perfect line and drifts just a little towards somewhere else. As the models improved, another thought took shape in the background. If jets of gas could push the comet so clearly, what did that say about the gases themselves? What exactly was boiling off into space with such force and such patterns? The answer to that question was not on the orbit plots. It was hidden in the light, in faint signatures of elements and metals carried away in the flow. For now, the astronomers watched their wandering visitor slide along its new adjusted curve, a course that refused to stay still. The dots on the screen looked quiet and ordinary, yet behind each tiny shift was a burst of invisible motion, and within that motion, a chemistry waiting to be read. Somewhere between the steady pull of the sun and the soft push of those unseen jets, 3-1-ATLAS moved on, carrying its secrets in a glowing shroud. And in the silence between each new measurement, the question lingered. like a thin line of light across the dark. What exactly is breathing out of that fragile, changing world? Out in the thin, pale light beyond Earth, 3i Atlas is no more than a soft blur against the dark. To the naked eye, if you could even see it, it would look like a faint smudge with a tiny tail, nothing more. But when that smudge is passed through the right kind of instrument, the comet stops being a blur and turns into something else entirely, a pattern of colors and lines, a whisper of chemistry written in light. In those thin, glowing marks, astronomers begin to read messages that seem to be written in metal. The tool they use is called a spectrograph. The idea is simple, even if the machine is not. Light from the comet enters a narrow slit, then hits a prism or a grating that spreads it out. The way a crystal in a window can turn sunlight into a rainbow. Instead of a smooth rainbow, though, the spectrograph shows bright and dark lines, sharp stripes where certain colors are stronger or missing. Each element in the universe, each type of atom, leaves its own special pattern of lines. It is like a barcode or a song where each note belongs to one instrument. Over years of study, comets in our own solar system have taught us a basic rule of thumb. Their solid cores, or nuclei, are mixtures of ice, rock, dust, and small amounts of metals. When they warm up and begin to release gas, the sunlight they reflect and the gas they glow with carry familiar fingerprints. Iron and nickel, the two metals that sit side by side in the heart of many planets and in the cores of asteroids, usually appear together. Their spectral lines show up in similar amounts, like a pair of twins that refuse to be separated. With 3i Atlas, that twin pattern begins to slip. As observatories stare at the faint light from its coma, splitting it into threads of color, something odd rises out of the noise. The lines that belong to nickel stand out clearly, bright enough to measure with surprising confidence. But the lines that should belong to iron lines that usually sit beside nickel like a shadow are weak, or missing, or buried so low that they can barely be seen at all. In the quiet control rooms on Earth, scientists lean closer to their screens. A familiar song is playing, but one of the main instruments is not their dot to make sense of this. Imagine listening to an orchestra recorded from very far away. The sound is thin and soft, but you can still tell which instruments are playing by the notes they hit. In most comet orchestras, iron and nickel are like two deep, steady drums. With 3i Atlas, the recording seems to carry only one drum. The nickel notes are strong. The iron notes are faint. On a spectrograph, this looks like bright nickel lines and nearly silent iron lines. To many astronomers, it feels like a code, a pattern that should be balanced but is not, a signal written not in words. But in VaporDot, the first step is not to jump to wild answers, but to test the quiet ones. Maybe the surface of 3i Atlas is layered in an unusual way. If one region near the surface is richer in nickel than in iron, and if that patch is what the sun is warming most strongly, then more nickel-rich gas could be escaping there. The iron could still be locked deeper inside, frozen in parts of the nucleus that the sunlight has not yet touched. When jets of gas burst out of these warmer patches, they might carry mostly nickel atoms and nickel-bearing molecules, leaving iron behind like a secret still buried under ice dot. There is also the question of what form the nickel takes once it leaves the comet. Some early analyses hint at exotic compounds, including one that sounds almost like something from a science fiction lab, nickel tetracarbonyl. In simple terms, this is a nickel atom wrapped in a coat of carbon and oxygen groups. On Earth, such a molecule is known from certain industrial processes and special laboratory conditions, where gas, heat, and metal interact in very controlled ways. To imagine it drifting in the thin, cold outflow of a comet is both strange and intriguing. It suggests that the chemistry near 3I Atlas may be moving through narrow, unusual pathways that are rare, but still natural. Most researchers stay close to these grounded ideas. They talk about temperature, pressure, and light, about the shape of the nucleus, the depth of its layers, the speed of its jets. They run models that show how, under the right mix of conditions, nickel-bearing molecules might form more easily than iron-bearing ones, at least for a while. To them, the comet is not a machine. It is a complicated piece of ancient rock and ice, behaving oddly but still obeying the rules of physics and chemistry. They remind each other that space is very good at surprising us with strange, but natural combinations of elements. Yet, outside those careful discussions, in late-night talks and quiet corners of conferences, other thoughts sometimes rise. If nickel is strong and iron is weak, if certain metal compounds seem to appear more than they should, some minds drift toward pictures of refined alloys and design mixtures. They imagine the way humans smelt ores, separating metals and purifying them for tools and engines. Then they glance back at the data and wonder, very softly, whether such a pattern could ever be a sign of some distant technology of metal arranged, not by chance, but by intent. These whispers do not become headlines. They remain what they are: gentle, speculative questions asked under the breath. The mood among most watchers is not fear, but awe. The idea that a comet could carry a strange imbalance of metals is already enough to stretch the imagination. Even if the cause is purely natural, it means that interstellar space may be full of hidden laboratories, places in which ice, dust, radiation, and time-run experiments go unplanned. A single comet, passing briefly through our sun's light, becomes a messenger from those hidden rooms. Its glowing nickel lines and quiet iron curves are part of a story about how matter can arrange itself in ways we would never think to design. Still, the question remains, resting just beneath the surface of every graph and chart. How do we listen more closely to such a faint, complex reply from the dark? The light we see has already traveled for millions of miles, weakened and blurred by distance. Our spectrographs are sharp, but not perfect. Our models are clever, but not complete. To hear the message more clearly, we need patience, more nights, more observations, more careful comparisons between this visitor and the comets we already know. Each new spectrum is like another letter in a script we are still learning to read. So, the comet continues on its path, slipping slowly away from the sun, its gases thinning, its glow fading. In observatories scattered across the planet, data files store the patterns it left behind. Slender lines where nickel shone, empty places where iron should have stood, hints of exotic molecules that might or might not be there at all. On the screens, those patterns look simple, a few bright streaks against the dark. But to the people who have watched them emerge, they feel like a message caught in transit, a sentence from an ancient traveler written in the softest ink. And as the night sky turns and the comet moves on, that unfinished sentence remains, hanging in the quiet, like a question that the universe has asked and is still waiting for us to answer. Chapter 10. Eyes around the sun. Word count, 1300. Out near the sun, the sky is not dark at all. It is a flood of light and charged particles. Inside that harsh brightness, the interstellar comet 3I Atlas makes its tightest turn around our star, slipping through perihelion like a small stone hurled through fire. From Earth's surface, it vanishes into the glare. No mountaintop telescope can safely look that close to the sun, but humans have already placed their own eyes in space. Around the sun and around Earth, a scattered ring of spacecraft keeps watch. Silent sentinels that do nothing but stare, measure, and send back streams of numbers. Each one looks at a different layer of reality-visible light. Ultraviolet glow, X-rays, the faint signatures of dust and solar wind. As 3IATLS sweeps around the sun, these machines turn toward it like lighthouses swinging their beams across a dark sea. One of the most patient of these watchers is SOHO, the Solar and Heliospheric Observatory. It sits near a gravitational balance point between Earth and the Sun, hovering in a spot where it can face the star all the time. SOHO's coronagraph blocks the Sun's blazing disk and creates an artificial eclipse, so the space around the star comes into view. In those images, the comet is only a thin shifting scratch of light, a tiny streak moving across the bright mist of solar wind. Scientists follow that streak as it curves around the hidden sun, proof that the visitor is still there even while Earth itself is blind. Farther along the sun's orbit, the twin stereo spacecrafts see the scene from different angles. One travels a little ahead of Earth, the other a little behind, turning a flat sky into a three-dimensional story. When stereo catches 3IATLAs, the comet's tail may look longer or more fanned out, gently bent by the flow of charged particles rushing away from the sun. Small curves in that tail tell scientists how easily the comet's dust is pushed aside, and how strongly the solar wind is sculpting its path nearer to our planet. High above the clouds, weather satellites like GOES-19 watch more than rain and storms. Some of their instruments measure X-rays and energetic particles from the sun, tracking the invisible space weather that can shake Earth's magnetic field. As 3IATLAS passes through this environment, the gas flowing off its surface meets the solar wind head-on. At those contact points, faint X-ray and ultraviolet glows may flicker into existence. GOES-19 does not see a picture of the comet. It records tiny bumps in its data, small rises in counts and energy that mark where this ancient traveler is being brushed by the sun's breath in low Earth orbit. The Hubble Space Telescope offers a closer, more detailed gaze whenever geometry and schedule allow. Above air and weather, it can turn its mirror toward 3IATLAs in brief windows when the comet is not too near the sun in its sky. Through narrow filters, Hubble collects slices of color from ultraviolet to visible light. Its images reveal jets in the coma, the fuzzy envelope of gas around the nucleus, and structure in the dust tail. Long exposures freeze the comet in place while background stars smear into trails, turning each picture into a portrait of a soft head and sweeping tail. Farther out, near the orbit of Mars, robotic orbiters circle the red planet, usually focused on canyons, ice caps, and thin dusty air. When 3IATLAS passes near Mars's orbital path, some cameras turn outward. In their frames, the comet appears as a faint moving point, never grand, never dramatic, just a tiny light that shifts position night after night. From that distant perspective, its presence confirms that this visitor is not just an Earthside story, but part of the shared sky of the inner solar system. If you zoom out in your mind, you can see all of these machines at once. SOHO fixed near its balance point, stereo drifting along tilted paths, GOES-19 circling Earth, Hubble sweeping. Overhead, Mars orbiters tracing loops around a rust-red world. Together, they form a loose shell of attention around the sun, a man-made constellation that listens in many different ways. Into this constellation, another eye may join, the James Webb Space Telescope. Webb sits farther out than Hubble, near a quiet balance point on the night side of Earth. Its mirror is tuned to infrared light. Most of its time is spent studying distant galaxies, newborn stars, and exoplanet atmospheres. But the same sensitivity that lets it see the first light from ancient galaxies can also feel the warmth of dust closer to home. If Webb turns toward 3IATLAS, it will not just see reflected sunlight. It will measure heat, turning the comet into a soft thermal shape of warm dust and cooling vapor. All of these observations flow back to Earth as quiet streams of data. Long after 3I Atlas has left a field of view of any single telescope, scientists sit in silent rooms, aligning SOHO images, stereo movies, GOES 19 graphs, Hubble pictures, and perhaps web spectra. They compare how fast the coma grew as the comet neared perihelion, how the tail bent when a gust of solar wind struck, how the brightness rose and faded again. Each instrument adds its own accent. Together, they form a fuller sentence behind the technical work. A softer question lingers. How does this visitor compare to the first two we have seen from other stars? Oumuamua arrived first, with no clear tail and a motion that did not quite fit the behavior of a normal comet. Borisov came next, more familiar, with a bright coma and steady outflow that looked much like our own comets. Now 3IA TLAs traces its path through the same inner sky, and the ring of observatories measures its every subtle change. Do its gases glow in the same colors as Borisov's? Or are some chemical fingerprints missing or unusually strong? Does sunlight push on it gently, creating tiny non-gravitational nudges like those seen with Oumuamua? Or does its path follow gravity more closely? When its tail meets the solar wind, does it twist and kink in patterns we expect, or in shapes we have not recorded before? No single telescope can answer these questions, but the network together begins to outline a pattern. The answers do not appear all at once. They arrive slowly, in small agreements between graphs and images and models. A brightening caught by SOHO matches a rising gas seen by Hubble. A quiet bump in X-ray counts fits a subtle change in tail shape seen by stereo. The story becomes clearer, but never perfect. Some pieces fit, others do not. In that mix of understanding and uncertainty, the character of 3I TLS starts to emerge neither entirely ordinary nor entirely strange by the time the comet has curved away from the sun and begun its long climb. Back toward darkness, most of the instruments have turned to new tasks. The sun keeps flaring. Earth keeps turning. Mars spins under its thin sky. Yet the memory of this past remains stored in servers and archives, a layered record made by a ring of eyes watching a single traveler. For anyone listening in the quiet of night, there is a gentle comfort in knowing that our small world has learned to surround its star with attention. Around one ordinary sun, fragile machines of metal and code have caught the faint light of an object from another system and compared it with two earlier wanderers that once crossed this same arena on a quiet night when the sky feels like a single dark blanket over Earth. The story of 3I Atlas slowly opens into a larger tale. This comet is not the first ancient traveler to cross our path from the deep between the stars. Before it arrived, two other visitors slipped through the cradle of silence around our sun, leaving thin trails of questions behind them. To understand what 3I Atlas really means, the narrator turns the camera of the mind backward in time, and the story becomes a trilogy. The first echo comes from 2017, from a faint streak of light moving too fast and at the wrong angle. Astronomers at a telescope in Hawaii noticed a point of light racing across the sky, cutting through the usual traffic of asteroids in a way that did not match any known orbit. They called it Oumuamua, a Hawaiian word meaning scout or messenger from afar. It was the first confirmed interstellar object ever seen passing through our solar system. At first, people tried to fit Oumuamua into familiar boxes. Maybe it was a comet, maybe an asteroid, maybe a fragment of some distant planet. But as more telescopes turned toward it, the more it refused to behave. Its brightness changed in a strange rhythm, as if it were long and thin, tumbling end over end like a drifting shard. No broad tail of dust appeared, no soft glow of gas. It looked dry, almost like rock, Yet its trajectory did something that caught everyone's attention as it moved away from the sun. Oumuamua sped up a little more than gravity alone could explain. The change was small but real, a tiny non-gravitational acceleration, as if some hidden force were giving it a gentle push. Some scientists suggested that gases might be escaping from its surface in a way we could not see, acting like invisible thrusters. Others wondered if it might be something stranger, maybe even a light sail pushed by sunlight itself. For most astronomers, the answer stayed simple: a weird but natural object. Still, a quiet sense of mystery settled in, like a whisper of stars, that no one could quite translate. Then, in 2019, another voice entered the story. This time, the visitor looked more like what people expected when they heard the word comet. It was called 2I Borisov, named after the amateur astronomer who first spotted it sweeping across the sky. Through telescopes, Borisov showed a classic soft glow, a bright nucleus wrapped in a gentle veil of dust and gas, with a clear tail stretching away from the sun. Here, finally, was an interstellar object that behaved like the comets we know. Borisov's orbit told the important part of the story. Its path was hyperbolic, like a curve that never closes, showing that it came from outside the sun's grip and would leave us forever once it passed through. Its speed was high, its trajectory steep, yet its chemistry looked familiar when split by spectrographs into bands of color. Water, carbon dioxide, and other common ices whispered of a world not too different from the frozen edges of our own system. Together, Oumuamua and Borisov became like two stones picked up on a long walk. They came from different rivers, carried by different currents, but both ended up in the same small hand for a brief moment. Now, with 3 IATLAS, a third stone has rolled in from the dark. In this chapter, the narrator lays them out on a simple table in your mind and turns them slowly under a soft light, letting their shapes and textures speak. There are patterns that all three share. Each one follows a hyperbolic orbit, a trajectory that bends around the sun only once before heading back into the wider galaxy. Each moves at a speed too high to be bound to our star, proof that they were born somewhere far beyond the planets. We know each object spends only a short time in our sky weeks or months when telescopes can track them. A brief visit in the endless night before they fade again into distance. They are passing traveler's dot, but the differences are just as important. Oumuamua appears long and cigar-like, or perhaps flat and wide, depending on which model you prefer, with brightness that flickers as it tumbles. Borisov is more like a classic dusty comet, its coma and tail thick and bright, its behavior in line with what astronomers expect from frozen ices warmed by starlight. 3.1 DTLAS, by contrast, seems to fall somewhere between and beyond. It carries a strong gas-rich glow and shows unusual signs in its metals and dust, with jets and mass loss that make its light curve and motion stranger to read dot in calm, simple language. The narrator explains that this is how science often works, by lining up the familiar and the strange side by side, and stepping back to look for hidden patterns. The solar system becomes a kind of crossroads where the paths of these unknown travelers briefly intersect with our own. For most of human history, people looked at comets as omens, messengers, or warnings. Now, with better telescopes and careful math, we see them as clues instead, samples from other corners of the galaxy, drifting through like messages in bottles. Imagining them this way changes how the sky feels. It is no longer just a ceiling above Earth. It is a slow river of objects, some born here, some arriving from the shadows between the stars. When you hear the names Oumuamua, Borisov, and 3I Atlas, you can picture three silent shapes moving through the soft glow of starlight. One odd and dry, one classic and dusty, one vivid and blue-tinged, each carrying a story written in ice, rock, And gassed out as the chapter moves towards stillness, the focus turns gently back to you, the listener. You are one person on a small, fragile planet lying under a sky that has started to reveal its visitors. You may never see these objects with your own eyes, but you share the same moment in time when they pass by. Somewhere, far from city lights, a telescope follows a tiny drifting shadow across the dark, turning photons into numbers, numbers into graphs, and graphs into understanding. The narrator does not ask you to solve the mystery or choose a side between natural and strange explanations. Instead, the voice invites you to rest in the feeling of it. The idea that, while you sleep, pieces of distant systems slip through the space around your sun, tracing graceful paths no comet has ever taken before. The memory of Oumuamua still lingers. The dust of Borisov still stretches in archived images. And now 3IATLS writes its own thin line into that growing record. By the time this visitor is gone, it will be only one more echo in a story that is still being written. It shows that our solar system is not a closed room but an open doorway. Somewhere beyond the edge of sight, other objects are already on their way in, turning slowly in the darkness, following trajectories we have not yet mapped. And as they move closer, the questions they carry drift ahead of them. Like a faint cosmic whisper, you can almost hear if you listen in the quiet between your breaths. High over the turning Earth, 3-1, Atlas glides through the dark like a pale brushstroke, crossing the sky in steady silence. No engine marks its path. No radio call announces its presence. It is only motion and light, an ancient traveler from another star, slipping above cities and oceans. Seen by almost no one. In a quiet backyard at the edge of town, a porch lamp clicks off and the night grows wider. A person in a thick coat steps out, letting the door close softly behind them. Their breath hangs in the cold air. On a simple tripod, a small telescope waits, its wide tube already tilted toward the place where the comet is supposed to rise. They unlock their phone. The screen a small square of glow against their glove. A star chart app shows a faint icon with a name that still feels strange. 3IATLS. The map says it is low, just above the eastern horizon, close to the thin line where dawn will soon begin to wash the stars away. They tap to center it. An arrow appears, pointing to what looks like empty sky. They nudge the telescope, watching bright points swim through the finder. A familiar star drifts past, then another, then only gray. They stop moving the mount and wait. The tracking motor hums softly, like a distant refrigerator. Somewhere in that gray, the comet is crossing the frame. Too faint to see yet, but there. Scenes like this are repeating themselves across the world. On rooftops, in fields, on balconies. That look out over seas of city light. People tilt lenses and mirrors toward the same patch of sky, guided by charts and messages shared online. Many of them will never see the comet as more than a fuzzy hint, and some will not find it at all. Yet the attempt pulls them into the same quiet rhythm. Step outside, dim the lights, look up, wait. Elsewhere, the watchers never leave their rooms. A live stream from a mountaintop observatory fills the screen of a phone or television. The camera shows a black field dotted with stars. Near the center, a faint blur sits motionless, or seems to. On some nights, it carries a gentle blue tint, like smoke lit from within. Beside the image, a chat window scrolls with short lines of text. Clear skies from Finland. Clouded out. In Brazil, seeing the blue, wow. A few ask questions. Why did its path change? Is that tail normal? The astronomer at the observatory answers in a calm voice, pointing out exposure times, filters, and the latest orbit data. They explain that 3IATLAs is not obeying the earliest predictions exactly. The comet's path shows small course changes. The kind caused by jets of gas and dust that act like tiny, uneven thrusters. To a computer, it is an adjustment problem. Update the numbers, refine the model. To the people watching from beds and couches, hearing words like anomaly and blue emission, it feels like a story that is still being written in a small campus observatory. A narrow dome slit opens with the slow grind of gears, letting the night air slide in. A lone graduate student sits at a control desk, fingers hovering over a keyboard. They load the newest ephemeris, a table of times and positions compiled from observatories and amateurs across the globe. Many of the data points came from backyards with small telescopes and patient owners. The big telescope slews into place, guided by those shared numbers. On the monitor, stars drift, then settle. A long exposure begins. When it ends, the student sees a short, soft streak. The comet, its motion smeared across the image. Each new frame adds another faint piece of its story. Later, the exact coordinates will be measured and folded back into the global pool, tightening the known path by a fraction of a second of arc. Not far away, another kind of observer works. With much simpler tools. In a cluttered yard, a person has only a camera on a tripod and a long lens, aimed at the comet's predicted spot just before dawn. They have seen sharp blue images from Japanese and European observatories, perfect stars, clean tails, and know their picture will not look like that. Still, when the clouds open for a brief window, they press the shutter again and again. Fingers numb inside thin gloves. Later, in a dim kitchen, they stack the images on an aging laptop using free software downloaded from a link in a forum. At first, the merged frame looks like static. Then they slide a contrast bar and a faint smudge appears where the chart said the comet should be. It is barely there, smaller than a fingerprint, but it is there. For a moment, the room feels very quiet. They have caught a traveler from another star with a backyard camera and a borrowed tripod. They upload the image to a social page for amateur astronomers, adding a short caption. 3i atlas from a very light polluted sky. First attempt. Replies appear from around the world. Gentle advice, small congratulations, shared excitement. The picture itself is modest. The feeling it carries is not. Someone who cannot sleep sees that post hours later, lying in the dark with their phone held just above the blanket. Outside their window, clouds hide the sky. Streetlights bleach the low clouds pale orange. They know they will not see the comet tonight, or maybe at all. Yet scrolling through images and star charts, watching live feeds, and reading small notes. From strangers, they feel less alone. Somewhere, people are awake under the same sky, looking up at the same visitor around the world. Professional papers slowly accumulate. Spectrographs separate the comet's light into thin colored bands, revealing familiar gases and dust and hints of more complex chemistry. Researchers speak carefully of possible explanations for its blue glow and subtle course changes. Most of what they say points toward nature. Uneven outgassing, odd-shaped surfaces that heat and cool in lopsided patterns. Comets, they remind everyone, are messy and active. Mystery does not always mean message. Still, the feeling that there might be more never entirely goes away. It lives in the quiet question that rises when a person sees that faint blue smear and thinks, without quite meaning to, why does this touch me so much? If this is only ice and stone, why does it feel like a sign? And if it were something else, some unintended signal written in orbit and light, would anyone know the difference, or would it look exactly like this? As phones dim and eyelids grow heavy, live streams continue to show the comet's slow progress. Data continues to arrive in distant servers. The visitor keeps moving, indifferent, following its long, cold curve out of the inner system. Its blue glow will fade. Other headlines will replace it. Its catalog number will settle into tables and databases. But for the sky watchers, something has shifted that will not fade so quickly. A thread now connects that backyard, that rooftop, that observatory, that hospital break room. It is a thin thread, made of shared coordinates and late-night messages, of small triumphs and quiet failures. It stretches beneath the path of a silent object that never knew it was being followed. Out in the dark, 318LS drifts on, leaving behind no sign that it was ever here, except in the memories of those who stood beneath it, feeling the weight of the sky and the strange comfort of knowing that, for a little while, they were part of the same fragile circle of eyes turned toward a single, mysterious point of light. Out in the dark, between the stars, small things drift. For a very long time. They are not bright like suns or wide like planets. They are crumbs, splinters, frozen dust wrapped around rock and metal. Yet, when one of these small wanderers falls toward a new star, it lights up, and for a brief moment, it becomes a story. 318LS is one of those wanderers. Before the blue glow, before the strange data, it begins like almost every comet story does, as a piece of something broken off, thrown out, and left to roam. When astronomers talk about comets, they often begin at the edge of a planetary system. Not the part with shining worlds and moons, but the faint, cold halo far beyond them. In our own system, they call that halo the Oort cloud, a shell of icy bodies so far away that sunlight is only a weak memory there. Inside that shell, tiny, worlds drift in slow motion, circling the sun on orbits so wide they might take millions of years to complete even a single loop. Most will never be seen by any eye, human or machine. To picture where comets come from, you can imagine a busy young star long ago. Around it spins a disk of gas, dust, and ice, like flour thrown in a circle on a dark table. Inside that disk, bits of material bump, stick, and grow. Some pieces become planets, some become moons. Others stay small, dirty snowballs, rocky cores, shards of metal and frozen gas. Giant planets like Jupiter act as cosmic bouncers, kicking many of these shards outward with their gravity. Some are flung all the way to the edges, where they settle into the deep freeze of an Oort cloud. Not all comets hide so far away. Some live closer in, among belts of rock and ice. Our solar system has the asteroid belt between Mars and Jupiter, and beyond Neptune lies another population of icy bodies in the Kuiper belt. These regions are like the leftover shelves of a construction site, full of parts that never became planets. If the orbit of one of these bodies is nudged by a passing star, by the gentle pull of planets, or by long, slow resonances, it can begin to fall inward, trading distance for speed. That fall toward the sun is when a comet's quiet life changes. As a comet dives in, sunlight finally has something to touch. Ice starts to warm and turn into gas, lifting dust and grains off the surface. Around the solid heart, or nucleus, a thin atmosphere forms, called a coma. Solar wind and light push on that gas and dust, stretching them away from the sun into long tails. This is the classic picture. A dark, ancient traveler, wrapped in a glowing veil, trailing streams of dust, and ionized gas behind it. Seen from far away, it looks almost gentle, as if it were simply brushing past on some timeless errand. Where did the material inside these comets come from in the first place? The story reaches back even further, to dead stars. When massive stars end their lives, they explode as supernova, throwing heavy elements out into space: carbon, oxygen, iron, nickel, even rarer metals. These pieces drift into clouds that later collapse to form new stars and their disks. In those disks, some of the heavy elements lock into grains, then into rocks and ice. So when you look at a comet, you are not just seeing ice and dirt. You are seeing bits of ancient stars, cooled and gathered into a small, fragile archive. If this is the standard story, 3IATLA should fit somewhere inside it. A fragment from the edges of another planetary system, kicked free by some distant giant planet, wandering in interstellar space for millions or billions of years until our sun's gravity pulled it close. As it fell, 3I Atlas brightened, grew a coma, and let out streams of gas and dust. Telescopes watched as it shed mass, losing more material than some models expected. Some noticed its odd, almost electric blue glow. Spectrographs hinted at metals and molecules not often seen together. On the surface, these details looked like a list of anomalies. But nature has many extreme corners, and astronomers know that rare does not always mean unnatural. In one observatory, a team runs computer models late into the night. They feed in possible mixtures of ices, water, carbon dioxide, carbon monoxide, ammonia, and sprinkle in different amounts of metal-rich dust. They adjust the size of the nucleus, the rate at which gas escapes, the spin of the comet. The software turns their guesses into simulated light curves and spectra. On their screens, graphs bloom. Brightness over time, color versus wavelength, subtle shifts in hue as the comet swings past the sun. In another lab, a group leans over spectrograph data from 3I Atlas, lines and bumps that look almost like the trace of a heartbeat. Certain lines confirm what they expect: water vapor, simple carbon compounds, oxygen-bearing molecules. Other lines are stranger. They might point to metal ions, or complex organics, or gas released from minerals that only break down at high temperatures. None of these things, taken alone, prove anything artificial. They can emerge in comets that formed in regions rich in heavy elements, or that were heated by radioactive decay, or that survived pass brushes with their own stars before being flung into the dark. Blue light, too, has a history in comet science. Some comets in our own system show a deep blue ion tail when charged particles from the sun strip electrons from gases like carbon monoxide or nitrogen, making them glow in specific colors. If 3I Atlas carries unusual amounts of these gases, or if its path through the solar wind is just right, its glow could naturally shift toward that eerie electric shade. Combined with cameras tuned to specific filters and with long exposure times, the blue might look stronger on screens than it would to any human eye in the sky. The heavy mass loss that surprises some observers may also have natural roots. If 3I Atlas is loosely bound, a kind of fragile rubble pile, instead of a single solid rock, then heating on one side as it rotates can cause landslides, jets, and outbursts. These eruptions can throw off large amounts of material in sudden bursts, changing the comet's brightness and even its motion. Small non-gravitational pushes from jets of gas can nudge its trajectory in ways that are hard to predict, especially when the exact shape and spin are unknown. To a telescope, the result looks like a comet behaving too wildly, when it might simply be very fragile. Astronomers search their archives for rare cousins. They find records of solar system comets that briefly glowed in odd colors, or that split apart, or that shed strange metals in their tails. Some came from the far Oort cloud. Some were captured objects from other populations. Each one, at the time, carried its own cloud of questions. Over years and decades, many of those questions found answers in updated models, better data, or new lab experiments. Thus, samples from comet missions, like tiny return souvenirs, showed how complex and surprising natural chemistry can be inside something that, at first glance, looks like a dirty snowball dot. So one way to tell the story of 3I Atlas is gentle and reassuring. It is a piece of ice and stone from a faraway nursery, rich in heavy elements from forgotten supernova. carved and cracked by eons of cold, then briefly set aflame by sunlight as it passes our star. Its blue glow could come from ionized gases. Its strange metals could be the fingerprints of an overfed birth cloud. Its heavy mass loss could be the sigh of a body that was always on the edge of falling apart. In this view, every line in the data is a note in a natural, if rare, song dot. And yet, even inside this careful, grounded picture, a softer question remains. Why do some scientists still lean back in their chairs after a long night of analyzing? Spectra and whisper, almost joking but not entirely, about artificial origins? Part of it is human nature, the pull of stories, the echo of old myths about messengers in the sky. Part of it comes from the timing, the way 3I Atlas joins Oumuamua, and Borisov as another strange traveler through our neighborhood in a short cosmic span. When patterns are few, our minds reach for meaning. If you are listening in the dark, maybe with your eyes closed, you can imagine both truths at once. On one side, there is the calm, patient work of models, lab tests, and comparisons, slowly pressing each anomaly back into the wide arms of nature. On the other side, there is a small, persistent feeling that something about this visitor is still slightly out of place, like a chord that does not quite resolve. Between those two sits 31ATLS itself, blue and fragile, fading as it leaves us. The numbers say it is only ice and stone, but in the quiet space beyond those numbers, a question still drifts, light as dust in a beam of starlight, far from busy streets and bright stadium lights, where the sun is only a pale lantern in space. 31ATLA drifts through the dark. Its tail is a thin blue haze, its core a soft spark against black. Telescopes follow its motion, computers trace its path, and on silent screens, the visitor appears as a changing line of light. To most people, it is a strange but peaceful comet, a distant story to fall asleep to. Yet, in a few quiet offices and observatories, another thought has taken root. What if this is something else, something more than ice and stone? That thought does not begin with rumor or fantasy. It begins with data. When astronomers pass the comet's light through a spectrograph, the light spreads into a rainbow crossed by bright and dark bands. Each band marks a different element. For 3IATLAs, some of those bands hint at metals that seem stronger than simple models predict. Nickel and other heavy elements appear more clearly than expected. Its path also bends in tiny ways that are harder to explain with gravity and sunlight alone. The picture is still grainy, but it is sharp enough for a few minds to lean forward. Among those minds is Avi Loeb, an astrophysicist known for asking bold questions about visitors from between the stars. In earlier work, he suggested that some unusual objects might be artificial thin sails pushed by starlight, broken probes, or pieces of larger structures drifting between systems. When 3I Atlas appears with a blue glow, metallic whispers in its spectra, and an oddly tidy chemistry, he and a small group of colleagues raise a calm possibility. Perhaps this visitor is not only a natural comet, but a fragment of technology, a relic of someone else's curiosity. They look at its incoming path, at the speed and angle with which it falls into our system, and ask whether it could be intentional. They show how a broad, reflective shape might feel sunlight differently than a rough chunk of ice, creating the small extra push that astronomers label as non-gravitational acceleration. They imagine the refined compounds as coatings or plating, breaking down the metals as clues to engineered materials vaporizing in the sun's heat. These are not proofs. They are carefully drawn what-ifs, like sketches laid over the data, like tracing paper over a faded photograph dot all around them. Is the larger community of comet scientists, dynamicists, and instrument experts. Most of them look at the same measurements and reach a quieter conclusion. The metallic lines might be real, they say, but the uncertainties are large. The orbit is unusual, but not impossible. Jets of gas from hidden cracks could twist the path. In complex ways, calibration can shift line strengths. Faint signals are easily confused. To these astronomers, 3I Tlas is a fascinating comet from another star, but there is no solid evidence that it was built by any mind at all. Their skepticism does not come from a lack of imagination. It comes from long experience with nature's ability to surprise. In past decades, comets have erupted, split, faded, and changed course in ways that models only caught up with later. An object that seems too smooth or too precise can, after more data, turn out to be just another expression of familiar physics. Because of this, when someone suggests an artificial origin, the reply is patient. Let us check again. Let us see. If a simpler explanation fits before we reach for the extraordinary doubt in meetings, emails, and quiet video calls, the conversation moves slowly. One team shares a study highlighting rich metals and refined compounds. Another group responds with a new reduction of the same spectra, showing how the signal shrinks when they adjust for noise and background light. Someone points to a kink in the orbit. Someone else runs a simulation where jets and dust release recreate that kink without any technology at all. The words used are cautious and soft, tentative, marginal, consistent with, not yet confirmed. This is how science holds bold ideas up to the light. If you are listening in bed, eyes closed, you might hear these debates as faint voices in a long corridor, never rising to a shout. Skepticism here is a form of care. Astronomers know that human beings are pattern seekers. We read shapes in clouds, faces on distant planets, messages in random static. When something strange arrives from the deep between stars, it is natural to imagine a messenger, a probe, or a beacon. History is full of examples. Canals drawn on Mars where none existed, signals that turned out to be pulsars or our own machines. With that history in mind, many scientists feel a quiet duty not to promise more than the data can carry, even when their hearts hope for company. Yet even the careful skeptics are not made of stone. Step outside an observatory at night, feel the cold air, and look up, and you may sense a different part of the mind awakening. In that stillness, it is easy to picture 3I Atlas as a vessel instead of a rock. Perhaps it carries instruments still working. Perhaps it is dead and drifting, the fossil of an old and distant civilization. Maybe its makers launched thousands like it, letting them wander between suns, sampling thin dust, listening for faint radio noise, never expecting any one small world to notice. These images live beside the facts, not instead of them. They are stories we use to sit with a rare event, until we can say more. From the outside, it might look like a fight between believers and doubters. But inside the field, the lines are softer. Many who see no good evidence for an artificial origin still value the exercise of checking. By asking, could this be technology? They are forced to define in detail what natural behavior should look like. They design better surveys, more sensitive spectrographs, and new ways to track faint objects near the glare of the sun. Even if 3I Atlas is completely natural, it leaves behind sharper tools for the next mystery that slips in from the dark. 4. You. Lying in the dark, all of this may blur into a single feeling. That somewhere beyond your ceiling, an ancient traveler is cutting across our orbit tonight, and human minds everywhere are stretching to meet it. Some cling to the comfort of only ice and dust. Others lean toward the fragile hope of maybe something more. Between them runs a narrow bridge built from data, equations, and quiet awe. Whether this object is a crafted shard or a natural fragment from a shattered world, it follows its path without hurry, answering only to gravity, light, and its On the slowly boiling surface. What changes instead is us. We learn how easily we can project meaning onto a silent piece of rock. We learn how steady we must be when the universe hands us something both ordinary and strange at the same time. Soon, 3IATLAS will be gone from our sky, too distant and dim to study. Papers will be filed and archived. Some will favor purely natural explanations. A few will keep the door to artificial possibilities slightly open. But outside the journals and data logs, the visitor will continue to move through a different space, the human imagination. There, it will remain a question with two possible shapes, a comet of blue ice or a relic of unknown hands. As you listen, imagine that small blue spark shrinking into the dark, leaving behind no message, no clear answer, only a faint trail of numbers and a memory of wonder. Even if it is only a natural traveler, its brief passage brushes against our sense of destiny. It reminds us that the universe is wide enough to hold both strict physics and impossible dreams, and that every quiet object gliding through the cradle of silence might carry, if not a signal from others, then a soft reflection of who we are. When we look up and dare to ask what else might be out there, out in the thinning light beyond Earth, the story of 3IATLAS is already turning toward its last quiet act. The comet has rushed in from the dark between stars, skimmed past the sun, in a brief blaze, and now begins to fall away again, not downward, but outward, along an open curve. Its orbit is not a loop that will bring it back. It is a one-way path that will carry it out of the solar system forever. Near perihelion, when it passed closest to the sun, 3IATLAS wore a wide veil of gas and dust. Sunlight struck frozen ices in its crust and shook them free, building a glowing plume that trailed behind like a torn banner. Now, as it climbs away from the sun's heat, that banner thins. The jets quiet. The bright tail that made it easy to follow shrinks like steam. Fading in cold air. We follow it in imagination, riding just beside its invisible lane. Inside the orbit of Mars, the sun still shines strong, a white lamp in a washed-out sky. Here the comet is smaller than most cameras can see, its core only a few kilometers across, wrapped in a faint halo. Small grains of dust peel away and drift off the main path, forming a thin ribbon that will linger in space long after the solid nucleus has gone. Below, Mars keeps its slow, steady track, a red coin glowing at the edge of sunlight. For a brief stretch of weeks, the comet and the planet share the same wedge of space, separated by millions of miles. No one stands on the Martian surface to watch this visitor recede. Its passage there is silent, unmarked, and soon over. Beyond Mars, the sunlight softens. Its pressure on the tail grows weaker, like a hand slowly letting go. The solar wind still blows outward, but it thins with distance as it meets the wider breadth of the galaxy. 3IATLAS glides past the orbits of the asteroid belt and the giant planets, where worlds with rings, storms, and icy moons move through their own slow dances. Their gravity nudges the comet's path, but never captures it. Bit by bit, the sun's family gathers behind the traveler, shrinking into a cluster of faint paths and distant points of light. Far beyond the last massive planets lies an unseen border called the heliopause. Inside that shell, the solar wind dominates, carving out a bubble in the thin gas between stars. Outside it, the galaxy's own material and fields press in. In the long years to come, 3IATLAS will cross this boundary, moving from a region shaped by our star into the wider sea of the Milky Way. By then its bright days will be finished. The ices that once boiled off to make its tail will be locked and still. Its nucleus will cool into a silent, irregular lump of rock and ice, traveling through almost total darkness. From Earth, there will come a night when no telescope can pick it out anymore. The comet will have grown too faint, too far, its light, lost in the general grain of the sky. But in the mind's eye, we can keep following, letting time stretch beyond any human life. Years slide into decades, then centuries. The comet drifts between scattered stars, moving through the soft, thin matter that fills the space between suns. Every so often it passes near another star still at distances measured in trillions of miles, but close enough that the star's gravity tilts its path by a fraction of a degree. Picture one of those systems, a star not so different from our own, wrapped in its own family of planets. On one of those worlds, there is an atmosphere, weather, maybe oceans and continents. There are beings there, whatever their shape, who have built tools to study their sky and to listen to the darkness around them. One calm night, their instruments record something faint and strange. A small object, moving fast on a path that does not belong to their star. Its spectrum hints at ices and metals they know, but in unusual blends. Its orbit is hyperbolic, cutting through their star's domain like a guest with a one-way ticket. They label it as an interstellar comet, give it a name in their own language, and trace its curve against their constellations. If they could map that curve backward with enough care, they might discover that countless years ago this visitor passed near another star, a pale yellow one with small rocky planets inside and gas giants outside. For a short span of months, it glowed in that system's inner regions. Radio dishes, sus, hummed below it. Fragile creatures of water and carbon turned lenses toward the sky and whispered about a third known interstellar wanderer. To them, it was 3IA till Ace. To the
later watchers, it is something else. To the galaxy, it is simply one more ancient traveler passing through. Those distant observers will never know our names. We will never hear their voices. But in that shared invisible link, two civilizations watching the same small traveler at different times, there is a quiet thread tying their night to ours, two sets of eyes under two different skies, separated by ages and light years, looking up at the same messenger and wondering what else crosses the dark. Back on Earth, under our sky, the comet's passage is already done. The headlines have scrolled away. Daily life has closed over the brief excitement like water smoothing after a stone. Yet traces of that visit remain. On servers in quiet rooms, in observatory logs and stored spectra, 3I/Atlas is still present as data and as memory. Astronomers will return to those records. Some will compare 3I/Atlas with the earlier travelers, searching for patterns that might show how often such objects pass through, or what they can tell us about the systems that flung them out. Perhaps one day, a mission will be launched with these wanderers in mind. A fast, nimble spacecraft ready to meet the next interstellar comet on its way through, to fly beside it for a while instead of watching it from afar. For you listening now, 3I/Atlas exists as a picture in your mind, an ancient traveler curving around the sun and slipping back into the deep. You may never see it with your own eyes, but the act of imagining it, the long arc, the thinning plume, the final fade into darkness, is something you carry. It is a quiet agreement between you and the sky, that even brief, passing things are worth noticing. In the end, the comet does what physics says it must do. It follows its trajectory, obeys gravity and momentum, and vanishes into the cradle of silence between stars. The mystery lives elsewhere, in the way its brief visit touches our sense of scale and time. We take this encounter and turn it into questions. How many more such messengers are out there? What stories of other systems do they bear, locked in their frozen layers? What does it mean that our solar system is not sealed off, but open to these wandering guests? As the last useful photons from 3I/Atlas fade from our detectors, the sky returns to familiar patterns. The constellations rise and set. Planets brighten and dim on their slow loops. The comet is now only an invisible point, already farther than we can easily imagine, already woven into the quiet fabric of the galaxy. And yet, in another sense, it has not left us at all. It remains in the questions we keep, in the way we listen a little more carefully to the darkness, in the hope that we will notice the next faint streak when it appears. The comet moves on into endless night, but under this small dome of air and cloud, Its passage lingers as a glow in our collective memory. A gentle reminder that even as things depart, they leave behind a trace of wonder that never quite fades. With 3I/Atlas now far from the sun, the comet that once filled observatory screens has shrunk to almost nothing. In a darkened planetarium or a bedroom with the lights off, you can imagine it as a tiny moving dot on a star chart, drifting closer to the edge. The blue coma that once flared so brightly is now only a story. The strange anti-tail that pointed toward the sun instead of away from it, the slow, unsettling shift in its trajectory. These have become lines in a logbook, frames in an archive, memories in the minds of the people who watched. On Earth, life sinks back into its ordinary rhythm. Traffic lights change. Phone screens glow. People wake up to alarms, answer messages, cook dinner, and fall asleep without thinking about cold objects sliding through deep space. Yet above all of this, beyond the airplanes and weather clouds, the sky is still moving. The comet does not know that no one is looking at it anymore. It continues on its path, obeying gravity and its own slow evaporation, an ancient traveler passing through. Astronomers who spent months tracking 3I/Atlas now turn to other targets. Some point their telescopes toward exoplanets crossing their stars, reading their thin atmospheres with delicate spectrographs. Others watch variable stars pulse like cosmic heartbeats, or map the faint glow of distant nebulae. Still, in quiet breaks between observations, the memory of the blue visitor returns. They remember the first time it appeared on their screens, as a faint smudge. They remember the surprise at its metallic signature, the strange chemistry that made it glow so fiercely blue, the subtle course changes that did not quite match prediction. For a fragile species on a blue world, these visitors are more than data. They are reminders that the solar system is not a sealed room, but a crossroads. Fragments of other star systems pass through, bringing with them atoms forged in supernovae, cooled in distant Oort clouds, and shaped by suns we will never see with the naked eye. 3I/Atlas, with its anti-tail and shimmering coma, carries in its dust the history of somewhere else. A place with its own planets, its own season of formation, its own quiet dramas unfolding under unfamiliar constellations. As the comet climbs past Jupiter's orbit and into the thin, pale sunlight beyond, its tail thins and then vanishes. What once was a dramatic fan of ionized gas becomes too faint to see, even with powerful instruments. From the perspective of a spacecraft, if one were there, the comet would look almost ordinary now. A dark, irregular nucleus, venting wisps of gas into the vacuum. Behind it stretches a path of particles, a fading trail that will slowly spread out along its orbit, a ghost of its crossing. Far behind, Earth keeps turning. On one side, daylight spills across cities and oceans. On the other, night rises gently, and stars appear one by one. Somewhere in that night, a person steps out onto a balcony, or sits near a window, or lies in bed with the curtains open just enough to see a sliver of sky. Maybe they heard the news about the comet only in passing. Maybe they followed every update and watched live streams from mountaintop observatories. Either way, the sky above them is the same sky 3I/Atlas once crossed. The narrator's voice softens, as if speaking from that balcony beside you. Over your head, the Milky Way stretches like a pale river, its countless stars woven into a single band. Hidden among them are pulsars, rapidly spinning neutron stars, compact remains of collapsed suns. They flash beams of radiation into space like lighthouses, sweeping unseen across your sleeping planet. Nearby, or at least nearby on galactic scales, lie nebulae where new stars are being born, their gas clouds glowing softly in the dark. Against this vast background, Earth is a small, fragile place. Thin air, shallow oceans, a narrow shell of warmth wrapped around a rocky core. And yet, it is from this tiny cradle that minds have learned to send telescopes into orbit, to build spectrographs that split starlight into rainbows, to track a faint blue glow and say, "There, something from another star is passing through." The knowledge itself becomes a kind of shelter, a way for a vulnerable species to feel less alone in the dark. 3I/Atlas is now only a point in long columns of numbers: right ascension, declination, velocity, magnitude. The orbit is plotted, the uncertainties narrowed. Software projects its future path for thousands of years, a long arc that curves through interstellar space, bending slightly as it feels the distant pull of other stars. On paper, it looks simple, just a line. But behind that line is cold dust, trapped gases, tiny shards of rock woven from elements created in explosions older than any story humans have ever told. As you breathe slowly, listening, you might notice how many of these stories begin the same way, with a small dot of light moving where no dot should be, a comet with an odd tail, a star flickering in a strange pattern, a radio signal that pings once and then never repeats. Each time, the pattern is the same. First comes surprise, then measurements, then long nights of checking for errors, testing models, arguing over explanations. Most anomalies fade into ordinary answers. The comet is natural. The star's flicker is dust. The signal is noise. And yet, each brief disturbance teaches something. A new trick of physics, a fresh detail about how the universe behaves when no one is watching. In this way, 3i/Atlas joins a growing family of visitors and mysteries. Oumuamua with its strange acceleration. Borisov with its more familiar, dusty tail but alien chemistry. Small asteroids that skim close to Earth, placing new plans on the desks of people who track them. In the long run, each of these becomes part of a wider pattern. Proof that space is not empty, that our solar system sits in a slow, constant rain of travelers from elsewhere. The tone settles into something like a lullaby. You can imagine lying back and feeling the planet rotate gently under you, like a ship turning on a calm sea. Above, the sky is never truly still. The constellation you see tonight is not quite the one your great-grandparents saw, and not quite the one your great-grandchildren will know. Stars drift, ever so slowly, across the firmament. Comets like 3i/Atlas slice through on steep, tilted orbits, visit for a heartbeat of cosmic time, and then recede into the dark. In that drifting, there is comfort. The universe is larger than your daily worries, larger than deadlines and traffic, larger than arguments that seemed, for a moment, to fill your whole world. Somewhere, pulsars still spin, nebulae still glow, and an ancient traveler continues its silent arc away from the sun. Your concerns are real, but they are not all that exists. You share this moment with galaxies, with dust, with light that has been traveling for billions of years to arrive at your eyes. Before sleep, one last thought lingers. If 3 interstellar visitors have already been seen in such a short span of human time, how many more have crossed the solar system unnoticed? How many dim comets, dark fragments, or silent probes have slipped through the outer reaches of our orbit, too faint or too fast for our instruments to see? Somewhere out in the dark, another unknown traveler may already be on its way, carrying in its frozen shell secrets of a star we have never named, secrets we may one day hear as a faint cosmic whisper on some future night.